Okay, this week we're going to have a look at something called the wave function. By that we mean we're going to turn something like this involving sine and cosine into something involving either sine and cosine but with what we call a phase angle. So over this week we're going to learn how to turn that into this sort of thing. That's called the wave function. Now the first lesson we're going to do is how to solve equations of this type here. Yeah, where we've got k cos alpha equals a number and k sine alpha equals a number, where k is a number bigger than 0 and alpha is between 0 and 360 in degrees or 0 and 2 pi in radians if it's a radian question. Now, before we do these, you need to remember a couple of identities before today's lesson. First of all, if you remember that sine squared of anything, call it alpha in this case, plus cos squared of alpha gives you 1. That's one of our identities. Okay, you can assume that. The second bit we know is that sine alpha divided by cos alpha equals tan alpha. You need to know that identity as well. And with some of them, you might need to know your exact values for trigonometry as well. Okay, let's go through what we're going to do to solve this sort of equation. Okay, let's look at this type of simultaneous equation and let's think about the technique we're going to use. The first thing I'm going to look at is I'm going to look at how I work out what k is. Now to do that, I'm going to square and add these two equations. So you're going to have k squared cos squared alpha plus k squared sine squared alpha. That's those two things squared and added equals this, squared and added. Okay, if we take out k squared, we've got cos squared alpha plus sine squared alpha inside the bracket. But if you remember from what we just looked at with our identities, that's 1. So that gives me k squared equals a squared plus b squared. Now, we know k is positive because it was defined as that at the start, so that means I can always use that k is just the square root of a squared plus b squared. I can always use that, okay? That's just to show you where it comes from, but all I need to do is square that, add them together, take the square root, and that's k. That's probably the more straightforward bit of this. The next bit, what we have to do is we have to work out what alpha is. But we do know if I divide this one by that one, I've got k sine alpha divided by k cos alpha. Okay, and that's going to give me b over a, isn't it? That's just that divided by that, and that equals that divided by that. Now, that gives me, now the k's will cancel out, we've got sine over cos. If you remember, our other identity was sine over cos is tan. So that gives me tan of alpha equals b over a. But I need to be a little bit careful here because remember, we're not always dealing with a first quadrant angle. Do you remember all sine, tan, cos? First of all, I can always work out what the inverse tan of b over a is. That'll give me my first quadrant angle, provided make sure it's positive, okay? So if we're going to do that, a way of saying positive is to do that sort of magnitude. So I want the positive. So what I'm going to do is work out my first quadrant angle, okay? I'll call it F for the first quadrant angle. It might be my answer, it might not, that I'm looking for. But I need to look at a couple of things. This bit, B, is the sine. A is the cosine. Now, if B is positive, okay, B positive would have to be either that one or that one, wouldn't it? It'd have to be there or there. Similarly, if B was negative, it would have to be there or there, wouldn't it? Because it's sine negative. If we looked at it the other way round, okay, if we looked at what about if A, which remember A is the cosine, so if A is positive, the cosine would have to be positive, which would be there or there. Okay, but if A happened to be negative, that means the cosine is negative, it would have to be second or third quadrant. So we can actually work out which quadrant we want. Not two quadrants. I don't just know that tan is positive or negative. I know that sine is positive or negative and cosine is positive or negative, which enables me to narrow it down to one quadrant. Okay, let's have a look at a couple of examples, and I think you'll find it'll make a lot more sense then. Okay, let's have a look at these two. Remember what we said. To work out k, we just square and add the two numbers and take the square root. That's all we ever do to work out k. So in this case, that's a Pythagorean triple. It gives us 13. Okay? So the next step is we do k sine alpha over k cos alpha. Remember, that gives us tan alpha. And that's equal to 12 over 5. So first of all, I'm going to do the inverse tan of 12 over 5. And that gives me as a first quadrant angle roughly 67 degrees. But then let's look at it. Look, the cos is positive there, and the sine is also positive. And if we think of our, all sine, tan, cos, sine positive is those two, cos positive is those two, it must be a first quadrant angle. So, alpha is therefore 67 degrees. Okay, so we've worked out k is 13, alpha is 67. What we've got here is we've got k being just these two numbers squared, added and square rooted. Okay, which is going to give us in this case root 13. I'd just leave it as root 13. That's an exact answer. Generally, exact answers are the best sort to leave, unless you're asked for a decimal. So just leave it as root 13. Next, we know k sine alpha over k cos alpha is equal to 3 over minus 2. Okay, so, and that's equal to tan alpha. Now what I'm going to do first of all is I'm going to do inverse tan of 3 over 2. I'm going to work out that first quadrant angle. If I do that, that gives me 56 degrees. But now we need to consult our cast diagram again. Remember, all sine, tan, cos. Here we know sine is positive, isn't it? Now sine is positive in those two, all and sine, yeah? But look, we've got cos is negative. Well, cos is positive in those two, so it is negative in those two. So we can see where those two agree, it must be a second quadrant angle. So the actual angle we want is going to be 180 minus 56 degrees, which is going to give me what, 124 degrees. Okay, that's how we do these. The only difference to that is if we were in radians, yeah, work it out in degrees as we did here. Then remember, if it was radians, at the end you'd need to multiply it by pi over 180. Okay, so if you multiply it by pi over 180, it turns it into radians. Yeah? So if you want radians, multiply by pi over 180. That's the factor, the conversion factor. Okay, you should be able to have a go at the first exercise now.